Good morning, INTERWEB. Today is February 25th, 2019. 5 years ago today, I uploaded my first Artifexian video. So, to mark this occasion, I thought it'd be a cool idea to watch that first video and see if it's held up over time. It's called Evolution of Low Mass Stars, and let's give it a go.
YouTube, Edgar here, and welcome to Artifexian. Here you will learn everything you ever wanted to know about world building, and then some.
Okay, so straight off the bat, right? The logo, I really like the old logo. It's a bit involved. There's lots of things going on. For anyone who doesn't know, it's Ogham, or at least a stylized version of Ogham, which is an ancient Irish script. My biggest problem here is that I sound like I've huffed a whole bunch of helium, which is just not good. Somewhere along the line, I was told that the camera takes away about 20% of your personality, so you have to compensate. And I figured a microphone would do the same, so I was like, let's make sure I'm super happy and bouncy and yay! It's just not good. Also, the aspect ratio isn't 16:9. It doesn't fit the YouTube player. I had yet to figure out how to change aspect ratio on my camera. So yeah, this is rough.
I think understanding comes before creation. So before we build a sun,
that voice, yeah, it's not good.
We must first ask the question, what is a sun? Well, a sun is a star, and a star is a massive luminous sphere of superheated gas held together by gravity. But let's look at things in more detail. Okay, so stars form in structures called giant molecular clouds which exist in the interstellar medium.
The content's good. My problem is the graphics. Also, I had image stabilization on my camera, and apparently there's this weird thing that if you have image stabilization on, and you have it on a tripod and you're doing a time-lapse sort of thing, it causes the pictures to shake. So this whole video is making me a little bit sick watching it. It's quite rough, but the content is good.
And they're comprised mainly of hydrogen, some helium, and little bits of dust. These clouds are thinly dispersed throughout space and are typically between 50 and 200 light years across. They are also very cold, something in the order of 10 Kelvin. To put this in perspective, a block of ice is about 270 Kelvin. Over time, gravity will cause the cloud to collapse in on itself and begin to form knots of matter. Due to Newton's law of universal gravitation, over time more and more matter will clump together.
Oh, look at that. I tried to do a sly thing with the notches, have them appear on their own, but I couldn't even do that right. Like there's bits where my hand is stuck on screen where it's just like, why didn't I just take the next slide, Edgar? Like, what's going on? Oh, and I remember as well, the way these were shot was essentially just a bit of paper strapped to a bit of MDF and these two insanely hot halogen building site lamps pointing at the piece of paper. And it used to get so sweaty and so disgusting. It was, yeah, those were really difficult to make, those early videos.
Knots. As more matter collapses, the density increases, gravitational energy is converted into heat, and the temperature also increases. When the temperature is high enough, the now spherical gaseous clump will begin to dimly glow and a protostar is born.
I believe a question mark is needed in that speech bubble.
After the birth of a protostar, the density and temperature will continue to rise until we reach 18 million degrees Kelvin. At this point, the temperature and density in the core of the protostar is high enough to achieve thermonuclear fusion. Thermonuclear fusion is the process by which atoms collide.
That's not entirely in focus, Edgar. Also, a huge problem here is that I'm essentially aping miniphysics style of making videos, and that wasn't to kind of like get on board the miniphysics train and try and leech off some of that success. It's more that I had no idea how to make videos, and Henry Wright from Miniphysics did a video with Brady Haran discussing how his videos are made, and that was kind of my in. I was like, oh, that's how you make a video. Great, I'll start making videos like this. So it wasn't a conscious decision to ape miniphysics. It just, that's the way it played out. I am glad I've moved away from miniphysics style videos, and I've tried to like forge my own kind of stylistic identity.
Hydrogen atoms are being forced together to form helium atoms. Once nuclear fusion occurs, our protostar is no longer a protostar, but rather a main sequence star. As a byproduct of hydrogen...
Oh yes, this bit. Okay, so I remember this distinctly. I don't know why I didn't just do more artwork here, but I drew this one slide and let it hang on screen for way longer than is logical, you know? Wait for it, you'll see it.
burning. Each time two atoms are fused together, a photon of light is emitted. This will cause the star to shine in its own right, rather than just passively glow. Our sun, for example, converts...
We could do with a change of artwork there.
400 million tons of hydrogen into helium every second, and as a result puts out 1 times 10 to the power 45 photons of light every second. That is 1 with 45 zeros after it. Even despite this immense power output,
it's too long.
It's a relatively calm period of a star's life. A star will spend the majority of its 10 billion year lifespan here happily burning away hydrogen and radiating off heat. Hydrostatic equilibrium between the gravity and the star's radiation pressure keeps it stable while it's in the main sequence. However, once all the hydrogen is converted into helium, nuclear fusion in the core temporarily stops. Gravity will then cause the star to start collapsing in on itself again, which, like before, increases temperature and pressure. The core will eventually get hot enough for the nuclear fires to reignite. Helium is now fused together to form a new atom.
Well done, Edgar. We got the focus right on that one. It's good.
Carbon. This helium burning will last a mere 100 million years or so, and because of the relatively low mass of a sun-like star, when all the helium is consumed, gravity will not be able to supply the necessary energy needed for further nuclear fusion. As a result of the heat produced from this helium burning, the star's outer layers will expand to hundreds of times their...
The red giant looks cute. And a huge problem as well with this is that this is essentially a science video and not a world building video. And again, at the time, this is 2014, and it was a couple of years into some really influential science channels kind of getting big. And I remember thinking, no one's going to want to listen to me talk about world building. I'm going to have to try and wrap it in a veneer of science to deliver that to people. So I was like, okay, I'll make these science videos about stars and stuff, and then I'll do this one speculative video on like how to construct a star for a fictional setting. And if I could change the way I did things in the early day, I just double down on the world building. Like there's no need really to understand all this stuff. Like it's really nice and stuff. But I should have just gotten straight to like, here are the equations that govern a star, and here's what that means for life on a planet, story implications, etc., etc. I just wasn't confident in the things I was doing.
Size. Here the star has moved off the main sequence and has become a red giant star. When our sun becomes a red giant, it would potentially expand up to 256 times its current size. At this point, its outer layers will
Is Pac-Man reference there?
engulf Mercury, Venus and Earth and continue extending out to near Mars' orbit. Our star will begin to shed its outer layers in fits and starts. Large amounts of matter are ejected into the interstellar medium in these cosmic bursts. The ejected material forms what is known as the Planetary nebula.
Again, like aside from the fact I'm speaking very quickly, I think the content is actually quite good. It's a fairly concise synopsis of what happens to low-mass stars throughout their life.
The outer layer is gone. All that will remain is a small core or stellar remnant. Gravity can no longer collapse this core due to a process called electron degeneracy. That is, electrons naturally wish to repel each other, and it is this repulsion that will balance against the force of gravity. This now stable stellar remnant is known as a white dwarf. A very
It's another cute little avatar right there.
dense object as massive as a star but only about the size of Earth. It is so dense that a teaspoonful of white dwarf material will weigh several tons. A white dwarf will then, for billions of years, peacefully radiate away any of its remaining heat. Once totally cool, it will linger in space for an eternity as a black dwarf.
I should have mentioned that black dwarfs are, I believe, hypothetical. Again, it's been 5 years since I looked into this, but I don't think the universe has been around long enough for white dwarfs to fully cool into black dwarfs. Or I don't think we're able to find black dwarfs, something like that. But I remember it being a hypothetical object, and I should have perhaps stressed that a bit more. And also the Team America reference is good.
So there you have it, the life and death of a sun-like star. Guys, please like and subscribe. Thank you so much.
Oh, look, the begging for likes and subscriptions. Smash like, everyone, hit that bell. Although the bell wasn't around in those days. But it's mad how I've changed.
For watching, and I'll see you next time. Edgar out.
And that's cool. Edgar Out has been around since the early days. Like, I've always said Edgar Out. That's never changed. And it's a nice little nod to sci-fi because, you know, Kirk Out from Star Trek and all that sort of jazz. All right, so that's it. That wasn't as bad as I thought it was going to be at all. And there's a couple of things that are funny about it that I could tweak. But overall, I think past Edgar, he did okay. He did okay. Yeah, so anyways, I hope you enjoyed this video. I have a Q&A on the way very, very soon. And then I'm going to have a world building video coming. Hopefully it won't take too long. Massive thanks to all the wonderful new Patreons who headed over to Patreon on the back of my last video. It means a lot. Thank you so much. Until next time, I'm gonna have to actually physically move. This is so weird. I'm not used to this. Edgar Out.